Hello everybody. In this lecture, as I will start with the rate law. Rate law is a formula that it will show you the connection between rate of the reaction and concentration of the reactant. For example, we have NO2 plus CO, we get NO plus CO2. Rate law for this reaction is equal to, we say rate equal to a constant number, we call it K, rate constant, multiply concentration of reactant, NO2, you give it exponent, and CO, again, you give it an exponent. M and N, we have to find them through an experiment. And if we have more than one reactant, like let's say in this case we have two reactants, at least we need to do three experiments, okay? 3 experiments to find M and N. Okay, so we need to do at least 3 experiments to find M and N. Okay, and what's a K? K is the rate constant. Again, we have to find that one, and I'm going to show you how to find the the K. Okay, what's the meaning of M and N? We call them order of reactant. That means they will show you if you double concentration of NO2, what will happen with the rate of the reaction, and the same thing with NO. For this specific experiment reaction, rate law is equal to K multiply NO2, exponent is equal to 2, and CO 0. So technically you can ignore this one and simply just say K multiply NO2, sorry about that, to the second. Okay. So based on this reaction, based on this rate law, a reaction is the second order to concentration of NO2 and 0 order to concentration of CO. What does it mean? Means that if you double NO, if you make NO more concentrated, let's double it, NO2 rate it will be 4 times 2 to the second, it will be 4, so the rate it will be 4 times faster. Okay. How about this one? If you double, if you double, the CO, if you change concentration of CO, nothing will happen with the rate of the reaction. Okay, nothing will happen. Okay, so here, rate law is equal to that. Okay, and so let me write it here. So if I double CO, first rate, it will be equal to the second rate. Like whatever you had at the beginning, or you started with, or first experiment, you will get the same one after doubling concentration of CO. Okay, because this one, it says exponent for it, it says 0. Okay, let's dive, in this coefficients, exponents, and try to understand them and find way actually to calculate them. But for now, I need to say this one, that m and n do not have anything to do with the coefficients. The coefficients here, it says 1, that one also 1. We have 1 nitrogen, here is 1 nitrogen. We have 1 carbon, 1 carbon. So m and n do not have anything to do with the coefficients. Those coefficients, we have to get them through balancing the reaction. But m and n, we have to do experiment. And if we have 2 reactants, at least we need to have 3 experiments to find m and n. Okay. So m and n, we call them order of reactant. M plus n, we call it order of reaction. Okay. So each one, we call it order of here reactant. M plus n, we call it order of the reaction. So for example that we came with, we said rate equal to K multiply 2 to the second. This is the rate law. Okay, rate law that we had. So I'm gonna say m is gonna be equal to 2, n it will be equal to 0. So m plus n is gonna be 2. So we say the reaction is gonna be second order reaction. Second order reaction. That means if you double the concentration, rate will be 4 times faster. Okay. Okay. Another example. Here. We have 2 mole from hydrogen plus 2 mole from NO. We get 1 mole nitrogen plus 2 mole H2O. It says rate law, experimentally they find the rate law says K multiply H2 to the first order and NO to the second. Look to this. For H2, we had the coefficient equal to 2. We got that one through balancing because we need to have here where it says we have 4 hydrogen on the right, we need to have 4 on the left side. And we have said 2 multiplied 2, it will be 4. Okay. But the exponent here is 1. So this one does not come from coefficients of H2. They found it through experiment. Same thing for NO. And because the exponent for hydrogen is 1, we say is first order to concentration of H2 and the second order to NO. And because we have 1 and 2, 1 for hydrogen and 2 for NO, rate of the reaction here, the order of the reaction, it will be third order. Okay, so the reaction, it will be third order. Okay. And what's the K? K is rate constant. Rate constant. And unit of K, unit of K is subject to order of the reaction. Okay. Unit of K is subject to order of the reaction. So that means always you need to have order of the reaction to find unit of K, and they will ask you about unit of K. Okay, so for now, let's refresh your mind from all the stuff from last lecture that I covered. We said a rate of reaction, we can write it as minus 1 over A multiply A, so change with concentration of A divided by delta T, and plus 1 over B change with concentration of B over delta T. If I see such a thing, I'm going to say I have a mole from A. I say a mole from A, a mole from A, and here I have B mole from B. Okay, B mole from B. So I say a mole from A transferred to B mole from B. How do I know I have only A on the left and only B on the right? I look to the sign. If it says negative, that means reactant. If it says positive, that means a product. Okay. So now check this. Rate equal to minus 1 over 2 delta N2O5 over delta T equal to 1 over 4 delta NO2 over delta T equal to 1 over 1 delta of O2 divided by delta T. We're going to follow the same method we did here. I see minus, so this is going to be reactant, and I see 2. So I say I have 2 from N2O5. Then so this one is positive. Because it's positive, you have to put arrow to show that you're moving to a product. How many? 4 from NO2. And this one says, whether they put the 1 here or not, it says 1 from O2. 1 from O2. This is the reaction. Okay. Question is can be like this. It says write a balanced reaction for which the following rate relationship are true. So they gave you the relationship is given. The only thing you need to do, you need to multiply the coefficients to the numerator and check the sign. It says minus, that means reactant. So this one, it can be answer. Next, see 4 NO2. I have only 1, so that's not a correct answer. Okay. And this one, another option, 2 from N2O5. I see 4 from NO2, here 4 from NO2. Oh, I have only 1 from O2. So the correct answer it will be A. Okay. I told you that I'm going to show you how to get the rate law. Here is a question that you will see, and they're going to say, find the rate law using this data. Okay. We have 2 reactants. We have 1 mole from S2O8 minus 2 plus 3 mole iodide. We get this product. I don't care about the product. I'm worried about the reactant. I need to know how many reactants I have. I have 2 reactants, so I need to have at least 3 experiments. So 3 experiments. And the way I'm going to design the reactions, every time I keep one concentration or one reactant, concentration of one reactant constant. Again, I will start, for example, with S2O8. initial concentration, it says 0.036, iodide 0.06. The second, so I do this experiment, I get the rate. Okay, so let's say you got the first one. Whatever you got, you're completely blind to the experiment, to the reaction, to the mechanism. You did it and you got this data. No clue till now. You want to get knowledge about this, reaction, and you want to find a rate law for it. What you need to do, you need to eliminate the factor one by one. You don't know whether it's second, first, zero order to SO2. So do one thing. Keep this variable, second reactant, constant. Okay. So I will do the experiment in a way that this concentration for a concentration of iodide is constant. So if anything happened with the rate, it's not going to be from iodide. It's not going to be because of the iodide. It's going to be because of the change with concentration of S2O8. We doubled this one. We want to see what will happen with the rate of reaction. We double it, rate of reaction 2 times faster. So that means it's a second order to S2O8. You want to figure what's the relationship with iodide. You need to keep S2O8 a constant. So for example, this one, we go with 0.036, 0.060. Design another experiment that this one is going to be the same for S2O8, but the concentration of iodide, you can increase it or decrease it and see what will happen with the rate. Check the third experiment. Third experiment, I keep the concentration the same for S2O8, but I double concentration of iodide. So now I want to know what will happen with the rate. Compare the rate 2 times faster. So that means is it second order to iodide. Okay. And here's the way you do it. First thing that you need to do when you see such a question, write a rate law and define M and N. Okay. Define M and N. So I'm going to call this one here. I will put the M for S2O8 and N for iodide. Just define them. Okay. We want to find those. So we go with this. As we have a rate law equal to K multiply S2O8 minus 2 to the power of M and iodide to the power of N. You can switch them. There is no really logic behind those. Just choose anything, X, Y, Z, whatever. Okay, you can call it N and M, A, B, whatever. Okay. Now, so this one is our rate law. I will pick two experiment that concentration of this time a concentration of iodide is the same. So it will be eliminated, and then I need to be worried about S2O8. I'm going to compare the rate of the second reaction to the first one. So rate for the second reaction, because I'm talking about second reaction, I'm going to say 2. K is a constant number, stay as it is. S2O8 for the second reaction to the power of M. Iodide for the second reaction to the power of N. And let's divide it by rate of first reaction. And that one's going to be K, S2O8 minus 2. Sorry, this one is 1, M, iodide 1 to the power of N. Okay, so rate for the second reaction. Second reaction says 2.9 multiply 10 to the power of minus 5. Divide by the first one. It says 1.5 multiply 10 to the power of minus 5 equal to K multiply concentration of S2O8 from the second reaction. Okay. From the second reaction, this number is equal to 0.060 to the power of m. My bad, this one is 0.036 36 to the power of m multiply 0.060 to the power of n. Divide by, again, k multiply. I think I missed this one because this one is 0.72 is the second order. This is 0.72. Okay, sorry about it. 0.72 is the second order, second reaction I said. This one is 0.060. Okay, here K, we have this one 0.036. Okay, 36 to the power of m. This one is 0.060 to the power of n. Okay. So as you see, I designed experiment or the reactions in a way that I can eliminate one of the variables. Right now I see 0.060 the power of n divided by 0.060 power of n. So I can cancel entirely this one by that one. So that means n is gone. K by k also will be cancelled. Whatever left is 2.9 divided by 1.5. So here we have 2.9 divided by 1.5. Okay, so it's 1.93. So we have 1.93 equal to, we have 0.072 to the power of m divided by 0.036 to the power of m. Because both of them are the power of m, I have the right to say 1.93 equal to 0.072 divided by 0.036 to the power of m. And the answer for this one is 2. So 1.93 is equal to 2 to the power of m. Answer for this one is 2. So we have 1.93 is equal to 2 to the power of m. So now find m. What's m? M is going to be equal to 1. It's not exactly 1 in this case, because this one is not exactly 2. Remember, you're using experimental data, so they're not going to be perfect. Okay, they will be a bit off. You will have some error. But the number here is going to be m, it will be equal to 1. Let's prove it. The way you do it, go with this. Why don't you get log from both sides? Log of 1.93 is going to be equal to log of 2 to the power of m. Reminder, log of x to the power of y is going to be equal to y multiplied log of x. So log of 1.93 is going to be equal to m log of 2. So m is going to be log of 1.93 divided by log of 2. And m is going to be around 1. Okay, so we have log of 1.93 divided by, okay, answer is around 90.5. 0.95. You can assume this is 1. Okay, so that's the way you get it. Again, you can simply cover this part. Let me go with better actual sheet. Cover this one. We have 1.93 is equal to 2. 1.93 is equal to 2. So I'm going to say 1.93 is to the first. It's going to be equal to 2 to the first order. Okay, and m is going to be around 1. Okay, so we got m. Okay, we got the exponent for S2O8. So I'm going to say order for S2O8 minus 2 is first order. Okay, because m is equal to 1. Okay, so now next one you will eliminate S2O8 because we figure what's a m. So I'm gonna go with third experiment, and I looked at the third experiment. Concentration of S2O8 is 0.036. I want to eliminate the S2O8, so I will choose same concentration for S2O8. And the first experiment has that one. Does it matter that I should divide 1 by 3 or 3 by 1? Not really. Any way you do it, any way like you do the calculation, the answer is going to be correct. So whether you go with rate of first divide by rate of third, or rate of third divide by rate of first, result will be the same. Okay, will be the same exactly. Okay, so now let's go through second one. So I want to find I, so I go with rate of third experiment divide by rate of first experiment is going to be equal to k multiply S2O8 third experiment, so say 3 power of m iodide to the power of n from the third experiment, divide by k S2O8 minus 2 from first experiment, the power of m iodide from first experiment, the power of n. Rate of the third experiment, it says 2.9 multiply 10 to the power of minus 5. Rate of first experiment, 1.5 multiply 10 to the power of minus 5. K by K, it will be cancelled, so let's keep them for now. Concentration of S2O8 from third experiment is 0.036 to the power of m. Iodide is 0.120 to the power of n. Divide by K. This one is again 0.036 from first experiment. First experiment, this one, iodide is 0.060 to the power of n. So K by K got cancelled. Entire this one will cancel. It will be cancelled by that one. So we're gonna get 2 or 120. 0.120 divided by 0.060, which is going to be 2 to the power of n. And this one is going to be 1.93. So 1.93 is going to be equal to 0.120 to the power of n divided by 0.060 power of. Again, you can rewrite it. Said 1.93 is going to be equal to 2 to the power of n. You will do exactly same calculation like the one I did for S2O8, and n, in this case, it will be 1. We have a number, we have 2 to the power of something. It has to be equal to 1.93, which is almost 2. So n has to be 1. Okay, so now I'm going to say order for iodine is first order. So we got M and N, M1, N1, M1, N1, rate law is equal to K multiply S2O8 to the power of M multiply iodide to the power of N. Put the number. So rate law will be equal to rate K multiply S2O8 to the power of 1 and iodide to the power of 1. Rate of order of the reaction it will be M plus N, 1 plus 1, it will be 2. So it's the second order. I said K, unit of K, is subject to order of the reaction. Okay. So here we're talking about K, and K is a rate constant. And unit for K is subject, unit of K is subject to order of the reaction. Okay. You go with this formula for K. K is equal, unit for it here, unit for K will be equal to M1 to the power of sorry, M to the power of 1 minus N, I will tell you what's the N, multiply S minus 1. Use this formula to get unit of K. So unit for K it will be M1 minus, what's the N? N is order of the reaction. N is equal to M plus lowercase n. So just simply add those exponents and put it here. So it will be 1 minus 2 multiply S minus 1. So unit it will be M minus 1 S minus 1. M minus 1 S minus 1. Okay, so we got the unit for K. We got the rate constant. Sorry, we got the rate law. We got the rate law. I have the rate law. Time to find K. How can I find K? Let's see from this experiment that we have. What do we have? Based on this formula, rate law, I need to have K. I don't have it. S2O8. I can choose any experiment, and put the concentration there. If I choose the first experiment, concentration it will be 0.036. Iodide it will be 0.06. How about rate? The rate is going to be 1.5 multiplied 10 to the power of minus 5. So technically I have everything except K. Choose any experiment. It doesn't matter which one. Just choose one. So I'm going to choose a first reaction. I have the rate law is equal to K multiply S2O8 power of minus, here minus 2 to the power of 1 multiply iodide to the power of 1. This is my rate law. From first experiment, I have the concentration. From first experiment, I have the concentration for S2O8 is equal to 0.036. Unit is mole over liter or molar. Iodide, I have it 0.060. 0.060 unit is molar. K, I'm looking for it. And the rate from first experiment is 1.5 multiply 10 to the power of minus 5, and unit is going to be molar per second. Molar per second. So let's find K. K is going to be equal to rate divided by concentration of S2O8 multiply concentration of iodine. So K is going to be equal to 1.5 multiply 10 to the power of minus 5 molar per second divided by 0.036 molar multiply 0.060 molar. You cancel 1 m by 1 m, you are left with another m, and you have second as well. So I'm gonna get K equal to 1.50 and 5 multiply 10 to the power of minus 5. I have 1 over second divided by 0.036 multiply 0.060. Answer is 0.00216. To have 2 sig fig, here 2 sig fig. Unit it will be molar. So now you go with 1.5 power of minus 5 divided by 0.00216. I got this one is equal to 3.24 multiply 10 to the power of minus 8. Unit is going to be 1 divided by molar multiply second. Molar multiply second. And this is the right unit that we got it for K. So for K, where was the calculation? I can't find it. Okay, so I got this one 3.24 multiply 10 to the power of minus 8 and 1 over molar multiply second. I want to double check this number and see whether I got it correct or not before I move forward. So I have 1.5 multiply 5 divided by 0.036 multiply 0.060. Okay, my number is different this time. It's 6.9 multiply 10 to the power of, yeah, this number is wrong. It can be 8. It can be 8. This one is wrong. So 1.5. Why I'm getting this one? Divide by 0.036. Yeah, this one is wrong. Sorry about that. Yeah, now it's suspicious to like an 8. It is 6.94 multiply 10 to the power of minus 3. Because at least 2 of them, they will be cancelled by this 2 0. So it can be 8. Okay, so we got the K. Okay, we got the K. So now I can say rate law is equal to K, which is 6.94 multiply 10 to the power of minus 3, 1 over m multiply s multiply S2O8 minus 2 multiply iodide. Okay, this is the rate law. Okay, and again, let's double check the unit for K. Unit of K, we said is the second order because we have 1 and 1 here, so it will be m1 minus n multiply s minus 1. So you go with m 1 minus 1 plus 1, which is n, multiply s minus 1. We get m minus 1 multiply s minus 1, and this is equal to 1 divided by m multiply s. And this is the right unit. Okay. So I showed you how to get the order of any reactant. Next thing it said, let's get order of the reaction. We got the order of the reaction, we got rate constant, and we got the unit of the rate constant. Okay. So now you have the rate in front, rate law in front of you. I can go with here one question. Tell me what will happen with the rate if you change this concentration to, let's assume 0.2 or 0.2.5. Okay. Technically, just put the number there and get the rate. And this is the third part of the question. It says calculate the rate of the reaction when concentration of each reactant is 0.2. Okay, so you have those 0.2. Just put the 0.2 here and 0.2 there, multiply it by K, and it will give you the rate of the reaction. Okay, let's go after it. So we go with rate. So I'm talking about part C. Rate has unit of molar over second. So we should get this one. K is 6.94 multiply 10 to the power of minus 3, and is 1 over molar multiply second. Multiply S2O8. It says go with 0.2 molar or 20 molar. Multiply it will be 0.2 molar. So I will cancel 1m. First, the second one stays as it is, and I have second here. So I have 0.4. 0.2 multiply 0.2 multiply. This is going to be 2.78 multiply 10 to the power of minus 4. So 6.94 power of minus. Oops. So rate of the reaction is going to be molar per second, and it will be equal to 2.78 multiply 10 to the power of minus 4 unit. You have molar, and 1 second here, divide by second. And check this one. I got the right unit for rate of the reaction. Okay, cool. So I showed you how to get the rate of the reaction if you have the rate law for it. Okay, so I want you to go through this one. It says find the rate law. Okay, find the rate law, okay, and get the K for it. When they say find the rate law, that means find the exponent for CO and Cl2. So you need to write this one. Rate law is going to be rate equal to K multiply CO to the power of M multiply Cl2 to the power of N. Find K, M, and N. You start with these two first. You have to find them, and then you will find K. Okay. And let me check here. So it says if you double Cl2, the rate, it will be, what's the rate ratio between them? 1.97 divided by 0.696 is 2.83. So we're talking about around, is it third or the second? Okay, so this one is 2. Okay, that one is 0.97 divided by 0.696, 2.83. Okay, you know what? Now that we got in it, let's go after it. Let's go after this one and get at least M and N, and K I will leave it to you guys. Okay, so I'm gonna start with this too. CO is the same, so that means the first thing that we'll get is gonna be N, exponent for Cl2. So we go with rate equal to K, we don't know it, COM, and Cl2 N. So go with rate of second reaction divided by rate of first reaction, K multiply concentration of CO from second reaction is 0.25 of M, and Cl is 0.80 divided by K multiply 0.25. This one is 0.40. Okay, K by K. All this one to be cancelled by 0.25. So you get rate 2 divided by rate 1. Rate 2, it says 1.97. Rate 1 is 0.696. Okay, so I get 0.80 divided by 0.40 to the power of N equal to 1.97 divided by 0.696. 2 to the power of N equal to 1.97 divided by 0.696. And this one is 2.83. Let's get the log from both sides. Log of 2 to the power of N is going to be equal to log of 2.83. So N, it will be equal to log of 2.83 divided by log of 2. Go with log of 2.83 divided by log of 2. And the answer is 1.5. The answer is equal to 1.5. Cool. So we got N. So N is equal to 1.5, which is equal to 3/2. Okay, 1.5 or 3/2. It doesn't matter how you write it. Next one, I want to get M. You want to get M, or exponent for CO, then eliminate the Cl2. Go with the second and third reaction. So this time I go with these two. Okay, I want to cancel this Cl, so I need to keep the concentration the same. So we go rate of third reaction over second reaction equal to K CO, sorry, not K1, it's K CO from third reaction is 0.50 to power of M. This one is 0.80 power of N. K, it will be 0.25 power of n, and this one is 0.80 to the power of n. So n, it will be cancelled, k by k. Rate of third reaction is 3.94. Sorry, this is the second reaction, my bad. Second reaction rate for the second reaction is 1.97. Check the ratio is equal to 2. So that means m is going to be equal to 1. We get 0.50 divided by 0.25 to the power of m equal to 2. 3.94 divided by 1.97, this is 2. 2 to the power of m equal to 2, so that means m is going to be equal to 1. Cool. So we got the rate law. Equal to rate k multiply CO to the power of 1 and Cl2 to the power of 3 over 2. Okay, this is really nice, because when it comes to unit of k, you have to add these two first. And let's find n, order of reaction. It will be m plus n, 1 plus 3 over 2. That's going to be 5 over 2. Okay, so unit of k is going to be 1 m to the power of 1 minus n multiply s minus 1. So it will be m 1 minus 5 over 2 multiply s minus 1. Answer it will be m minus 3 over 2 multiply s minus 1. Okay, so okay, we got it minus 3 over 2 to s minus 1. Okay. And use any experiment, whether you go with 1, 2, or third experiment, and find k. You can do a calculation and get the k. So as you see, first one, A and E have the right unit for k. M 3 minus 2 over m to the power of minus 3 over 2 multiply s minus 1, and you see the same unit for E. Okay, and how about the exponents? We got 1 and 3 over 2. Here it says 2 over multiply 1 over 2. So this one is wrong, because we know the exponent for CO was 1 and for Cl2 1/2. So I think I do have enough data to confirm that this one is wrong, and the correct answer is A. Okay, so I showed you how to get the rate law and also unit of k. And so till now we were talking about first, like the different in the order of reactions. But let's just go, briefly go through, order of reactions and unit of k again. I want to do it really fast. And I go with this one. N equal to 0, N equal 1, N equal to 2. When N is equal to, and what I mean by N is order of reaction, rate law is going to be K multiply A to the power of 0. Anything to the power of 0 is going to be 1. So rate of the reaction is going to be equal to K. That means rate of reaction is a constant number. Unit for rate is molar over second. So unit of K, it will be molar over second. And this one, we say here rate is equal to K. So I'm going to say unit of K also, it will be molar over second. In this case, we have rate is the first order, so it will be K multiply A to the power of 1. This is first order. So K, it will be rate divided by A. K, rate, it comes with molar over second. A, it comes with molar, so you get 1 over second, which is equal to S minus 1. And when N is 2, is a second order, rate, it will be equal to K multiply A to the second. So K is going to be rate over A to the second. You go molar over second for rate, divide by M to the second. You cancel M by M, you have 1 left. You get 1 over M multiply S, which is equal to M minus 1, S minus 1. So whether you know that formula or not, the formula that I showed you for unit of K, you can use this logic to find K. Okay. I'm going to stop here. Thank you guys. Appreciate it.